Here we have another recursively defined set of graphs S. I'll draw the first few iterations of the recursive rule here. Now this definition looks very similar to the one in the previous video. The main difference is this word one here. In the previous video it was an all, and that created complete graphs, and in this video you'll see that just one there will create trees. So we'll have a recursively defined set of trees S. Okay, so the elements are trees. So applying the basis to get us started, we have a single vertex. Now we're going to apply recursive rule 1. So when you apply the recursive rule, what you do is you look back at what came before in the previous stage, and you put that down. So first we put that down. Now the recursive rule says create a new vertex. All right, so I'll create a new vertex and add an edge from this new vertex to one of the vertices that came before. So that's what we got. It's the only option for recursive rule 1. Okay, recursive rule 2. Remember, we look back and we draw what we had before. All right. Now applying the recursive rule. So think about, so we create a new vertex, and now we connect that new vertex with a new edge to one of the two vertices that came from recursive rule 1. So we could either connect it there or there. Now notice what happens if we connect it there versus, let me draw this thing again, if we connected it there. Notice that these are in fact the same graph. So up to isomorphism, it doesn't matter whether we connect the new vertice with the new edge to that vertex, or if we connect it to that vertex, we get the same tree. So recursive rule 2 only creates one tree, and it creates this one. Okay, now recursive rule 3. So remember, we look back, say, what do we have before? Okay. So we had that before. And we create a new vertex, and now we have 3 choices of vertices that we can connect this to an edge with. We have that one, or that one. All right. So let's see. We could go here. Let me redraw what came from recursive rule 2 again to show you what the other possibilities. We have that, or we have that. Now notice that these two are in fact isomorphic. So up to isomorphism, we only have 2 things that are created in recursive rule 3. That's these 2 graphs here. So now applying the recursive rule a 4th time, remember I look back and I draw whatever's in recursive rule 3, I draw it and then apply the rule to that. Okay, so this first one we could unwind and change the length of the edges a little bit and make it look like that. This other one, let's see, we could go something like this. All right, so now think about it. Like if you, you can add an edge here, 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 or here. Now, let's see, if you add an edge here, that's the same as if you were to add this edge here. Think about how adding this edge here would be the same as adding this edge here. So when it comes to modifying this first tree that came from recursive rule 3, there's really only 2 ways you could do it. And those 2 ways are like this or like that. Okay, now similarly with this graph that came from before, from recursive rule 3, let's think about how we could modify that. So if you create a new vertex, you could go there, 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 or to there. And if you think about this a little bit, I'm sure you'll see that the only 4 that we could create, or the only 2 that we could create from this 4 choices of vertices, is this one, and this one. But then if you think, look what happened before. What we created above. We already created that one, right? Those are the same by isomorphism. So we get rid of that. So recursive rule 4 creates these 3 graphs up to isomorphism. All right. So you don't even have to really worry about if we drew some of these things twice with if we don't even think about what's isomorphic and we just draw every possible thing that we can think of where we apply the recursive rule, and we had say I had like some other graph here like this that was obviously the same as that first one there up to isomorphism, but it's okay if we drew too many in there. It really is not a big deal that you have to worry about the isomorphism so much. This is just a set of graphs. So if we draw the same one twice, we're all up to isomorphism. Isomorphic means they're the same. So if we draw the same thing twice, it's really no big deal. When we put it all into a set, the set S, repeats are counted as 1. So it really isn't going to be a big deal to write things twice or what have you. So all you have to really remember from all this is really just that we're creating trees every time, right? All of the elements you can see in S are trees. They're connected and they contain no cycles, right? Each of, like, that's a tree, that's a tree, that's a tree, that's a tree, that's a tree. Even though I wrote it twice, there's a tree, right? Everything that you see that it creates is a tree. That's what you need to see.